Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, chapter 2.5, compound interest formula. So there are only two vocab words. Compound interest formula, which is a formula where interest is going to get compounded, and we compound interest onto principal and interest, and that's why it's called compound. And then the annual percentage yield, APY, we'll get to as well. But example 1 focuses on the compound interest formula, and it says Jose opens a savings account with a principal P dollars. Okay. Principal P dollars. That pays 2% interest compounded quarterly. What is his ending balance after 1 year? Okay, so we're going to start off with the simple interest formula, I equals PRT. So over here off to the side, if I keep doing this, I equals P equals R equals T equals, well, we run into an issue here because they didn't give us a dollar amount. So the interest is what we're trying to find. P is just simply P in this case. R is 0.02 and time is quarter of a year. So let's just do that as a fraction, 1/4. So then we simplify this. I equals PRT. So I is going to equal principal times rate times 1/4. Okay, and then we can clean that up. And when I combine the 0.02 times 1/4, that can equal 0.02 divided by 4. And then we multiply the whole thing by some principal. Okay, so that is I. All right, and then what we're going to do for the second quarter, we're going to call that, and then we're going to call this balance from quarter 1. So the balance from quarter 1 is going to equal principal plus interest. Okay, so the balance 1 is going to equal principal P plus, and we're going to take this 0.02 over 4 divided or times P, and that is our I. And so since we have an I in this equation here, it's going to go here and we're going to substitute 0.02 over 4 P. So the balance after the first quarter would be the principal plus this interest amount. Okay. Okay, so now what we have is two terms separated by this plus sign. So this is a binomial, and they both have a value that's got P in it. So they have a common term, a like term, and I can factor that out. So if I factor out a P, that is going to leave me P times 1. Okay, so P times 1 is this P plus 0.02 over 4. So if I take P times 0.02 over 4, this will give me that 0.02 over 4P. So all I did here was factor out a P. Okay, so there's B1. Principal times 1 plus 0.02 over 4, which is 1 plus our rate divided by our quarterly compounding. Okay, so now what I want to do is find B2. I'll do this over here. So B sub 2 is going to equal B sub 1's principal plus interest. Okay, so B sub 2 is going to equal B sub 1 plus let's see. Okay, so the interest here would be, so B sub 1 is just this principal times all this. Okay, so that was principal plus interest for B sub 1. So then we take that principal, and then we're going to add the interest for B sub 1, which is going to become B sub 1 plus 0.02 over 4 times P. Okay. And we now have another term with B sub 1. Did I do this correctly? It's not P this time though. We now know our principal is B sub 1. Okay, principal. So let's get back here. Principal times this gave us our interest 0.02P. B sub 1 is our total, which is our principal plus our interest times the principal, or these values times principal. So B sub 1 is this. That is our initial value, principal. So B sub 2 is going to be the principal plus B sub 1. There's no B sub 1 there. It's going to be the principal plus 1 plus, or it's going to be 0.02. Struggling here. 0.02 over 4, but our principal this time is B sub 1. There we go. Okay, so the principal plus rate over divided by the time times our principal, which is what we got up here. See the P, we're just replacing the P with a B1 now. So B2 is the principal from B1 times 0.02 over 4 times B1. And then I can factor out a B sub 1 from each term. So I'm going to take a B sub 1 and parentheses 1 plus 0.02 over 4. But that simplifies to, or that expands to in this case, well, what is B sub 1? Well, B sub 1 is this P times, so as you can see right here, this is B sub 1. So I'm going to replace this B sub 1 with this right here. So this is going to be P parentheses 1 plus 0.02 over 4 close parentheses. So that's B sub 1. So it's B sub 1 times that. So I'm going to say times this. This is my B sub 1. And then it's 1 plus 0.02 over 4. And now I have the same thing. So now I can simplify B sub 2 as being principal times 1 plus 0.02 over 4 quantity squared, because something times itself is squared. Okay, so we're adding on, and we're going to do it one more time. Okay, so now we're going to work up here. And now we're going to find B sub 3. So B sub 3 is going to equal B sub 2 plus interest. Okay. And what is the interest? Well, B sub 3 is going to equal. So now what we're going to do, since we have a B sub 1 plus 0.02 over 4 B sub 1 for B sub 2, B sub 3 is going to be B sub 2 plus 0.02 over 4 B sub 2. Okay, so it's the principal from the second quarter plus interest times the principal from the second quarter, or the rate and time. Okay, so then B sub 3 is going to become B sub 2 plus, well, what is B sub 2? This is going to be, here, let's do it this way. Let's factor out the B sub 2 first, like we did before. So if I factor out a B sub 2, we're going to get 1 plus, and 0.02 over 4 times B sub 2 is just going to be 0.02 over 4. So when I distribute this, B sub 2 times 1 is B sub 2. B sub 2 times 0.2 over 4 is B sub 2. 0.02 over 4 B sub 2. So now we have B sub 2 here as this. Okay, so, well, what is that? Well, B sub 2 is right here. So now we're going to substitute this in. So B sub 3 is going to equal B sub 2, which is P times 1 plus 0.02 over 4 squared. And then we're going to multiply this piece. So this right here is B sub 2. So I'm substituting this in. So here's b sub 2 times this, which is 1 plus 0.02 over 4. Okay, well, this is going to simplify to b sub 3 equals p times, and this times this is 1 plus 0.02 over 4 cubed. All right, and one more time, b sub 4 is going to equal b sub 3 plus interest. All right, let me scroll down here and make some more room. And let me move this down or check for understanding here. All right, so let me just bring this up a little bit like so. So now we have b sub 4 equals b sub 3 plus the interest. So that means b sub 4 is going to equal, and it's really a lot easier just to go up to your steps and see what you did. Well, b sub 2 is now going to be b sub 3 plus, and it's going to be 0.02 over 4 b sub 3. Now b sub 4 is going to be equal to, and we're going to take that b sub 3 and factor it out, and it's going to be 1 plus 0.02 over 4. Okay, well, b sub 4 is now going to be b sub 3, which is p times 1 plus 0.02 over 4 cubed. So now this is my b sub 3, which I'm substituting in for this b sub 3, and it's going to be times that 1 plus 0.02 over 4. And now when I simplify that, I get b sub 4 equals p times 1 plus 0.02 over 4. And the powers, you add them and you get to the fourth power. Okay. Okay, so what has just happened? Well, we just found the formula for compound interest. Okay, and so what is it? Well, the balance after so many periods of time equals the principal times 1 plus r over t to the power of t. Okay. So now it's check your understanding. Your turn. I'll pause the video, see if you can do this, come back, and we'll see how you did. Okay, so the check your understanding, Rico deposits $800 at 1.87% interest, compounded quarterly. All right, so there's the key right there, compounded quarterly. What's his balance after 1 year? Round to the nearest penny. All righty, so here we go. I equals P R T. So I'm going to call this I sub 1, P sub 1. R and T never change. Okay, we're trying to find the interest after the first quarter, and it is quarterly. The rate is 0.0187, and the principal is $800, initial principal. Okay, so then the I sub 1 equals 800 times 0.0187 times a quarter, or divided by 4, either way you look at it. So I sub 1 is going to equal, and I'll get my calculator. I'm going to do something different this time. I'm going to store my answer so I'm not rounding until we're actually done. It might be a couple cents, but if you're a large bank, those couple cents add up. So 800 times 0.0187 parentheses 1 divided by 4. I could have said 0.25 as well. Enter, and it's $3.74. So it's 3.74. That one didn't get rounded, so I'll just leave it. So it was 3.74. All right, so then I'm going to do I sub 2. That was only the first quarter. That's how much interest we earned in the first 3 months. Okay, it's compounded. That's the key here. It's not simple. So the second interest is going to equal the principal from the second quarter, or from the first quarter added with the interest, RT. So the interest for the second quarter is what we're looking for now. And P, the second principal, is now going to be 800 plus that 374, which would be 803.74. Okay, so that's the one thing that changes. Now we're going to make interest off that interest. And the rate is now still 0.0187, and the time is also still a quarter. So I sub 2 is going to equal 803.74 times 0.0187 times a quarter. So my I sub 2 is going to end up being, and I'm just going to say plus 800 here just to get that 803.74 times 0.0187 parentheses 1 over 4. And I hit 7, 1 over 4. Okay, so 803.74 times 0.0187 times a quarter, and that is an interest rate here. So now watch what I'm going to do. I'm going to store, and I'm going to store it as A. So I'm going to do alpha A. Okay, so I hit this stow button, and I hit alpha A, and it's going to save that 3.7574845, and I'm going to hit enter. And that's the value. So I'm going to round it here, though. It's 3.76 approximately. Okay, so notice it's 2 cents more. Not much, but it's more. 3.76. Okay, so now that's after 6 months. So we have to do this 2 more times. So I sub 3, the interest from the third quarter, is going to equal P, the principal. Actually, that'd be P sub 2, wouldn't it? Or would it? This is initial principal, so I guess I would call that P sub 0. And this would be P sub 1. So I probably should be more careful there. Initial, I would call 0, and this is principal from the first quarter. And now we're going to use the principal from the second quarter. So I suppose I should call it P sub 0, the first one. All right, so anyhow, RT. So the interest from the third quarter is what we're finding here. And P sub 2 equals this 803.74 plus 376, or plus the A. So this plus my 803.74. And that's going to be 807.50. Okay, so I'm going to store that. So I'm going to hit store alpha B, and now I'm on to B. Okay, so it's 807.50 for an approximation. 807.50. Okay, rate is still 0.0187, and time is still a quarter. So I sub 3 is going to equal this 807.50 times 0.0187 times a quarter. So my I sub 3, interest from the third quarter, is going to be this, which is my P sub 2, times 0.0187 parentheses 1 divided by 4. All right, and that gives me 377.5, or approximately 378. All right, so really this should be an approximate, not an exact, whenever you have to round. And then finally, I sub 4 is going to equal my principal from the third quarter times my rate times my time. And I sub 4 equals my principal from the third quarter equals, and now it's going to be this. And my principal from the second quarter was B, so I'm going to take this plus alpha B, enter. And now we're up to 811.27. And my rate, and then my time. 0.0187 1/4. So I sub 4 is going to equal this 811.27 times 0.0187 times 1/4. So now my final interest is what we're trying to find here. And I'm going to take that 811 and I'm going to multiply it by 0.0187 times 1/4. All righty, and that is giving me $3.79 with a 0.26 after. We will round to 3.79. Okay, so this interest is 3.79. What is the ending balance after 1 year? So what I want to do is take my principal from the third quarter and add it to I sub 4. So my final balance is going to equal my principal from the third quarter, which is $811.27. And I'm going to add 379. So if I use my calculator to hit plus 811.27, I'm going to use more digits, so it's going to be 811.27. And I want to go out a little further just to see if that penny matters. 25352, 25352. Enter. And I got 815.06, and that 0.5 rounds up to 07. So it'd be approximately $815.07. Okay. Okay, example 2 says if you deposit P dollars for 1 year at 2.3% compounded daily, express the ending balance algebraically. So if we go back to our example, or number 1, this was compounded quarterly. And notice what we came up with. The balance equaled the principal times 1 plus the rate divided by that time frame, which is 4 quarterly over 4, and then 4 up here. All right. So we're going to use that. So if I write over here, I equals P equals R equals and T equals, rate is 0.023. Compounded daily is 1 over 365. Okay. Principal is P. That we don't know, it's just a dollar value. So we would say I equals, and it's principal times 1 plus, and if we go back and look at that, it's the rate over time to the power of time. So the rate is 0.023 divided by 365, and close the parentheses, and my exponent is that number of days in a year, which is 365. So there is, actually it's not interest, that would be the balance, okay? Because we're taking our principal times 1, which is our principal, plus the interest equals a total balance. So we should have B equals P times 1 plus 0.023 over 365 to the 365. So this will calculate our balance. So this piece here would be interest, and our balance would be added in automatically. Okay, so now it says check your understanding. Nancy deposits $1,200 into an account. So I'm going to say, oh, it's compounded monthly. So I'm going to say P equals R equals T equals. Notice I'm not using I anymore. So the principal is $1,200. The rate is 0.017, and the time is compounded monthly. That is 1/12. So I'm going to say my balance is going to equal principal times 1 plus 0.017 over 12 to the power of 12. So then I plug that into my calculator, and we get 1,200 parentheses 1 plus, and I'm going to do another parentheses for my fraction, 0.017 divided by 12. This first parentheses closes my fraction. So think of it as another parentheses in there. Okay, then I need to close the parentheses again and take it to the power of 12. And when I hit enter, I get my new balance of 1,220.56. So if I want to know what I is, all I do is take my new balance and subtract my principal, and it's $20.56. Okay, so once we calculate that formula, which was quite tedious, once we find the formula, substituting in now is really simple. Okay, so now let's do the extended understanding. So pause the video, see if you can do this, and then come back. Okay, so now it says Nancy receives 2 offers in the mail from other banks. One is an account that pays 1.38% compounded daily, and the other account pays 1.9% compounded quarterly. Would either of those accounts provide Nancy with a better return than her current account? And if so, which accounts? So let me scroll back up so we can see how much she would end up with here. And now we're going to do these 2. So let me do the first one. So it's going to be the balance from the first bank is going to equal principal times 1 plus, and its rate over time to the power of the time. All right. Actually, it's NT, but we'll talk about that in a bit. So then we get the principal being $1,200 from the last check your understanding times 1 plus, and now this rate is 0.0138 over daily is 365 to the power of 365. So there's one formula. And then let me do the green one up now. B sub 2 equals our principal. And I've already written that here, so let's just do 1,200 times 1 plus, and this rate is 0.019. And this is compounded quarterly, so that's going to be 4, and that's going to be 4. All right, so now let's calculate these. So I'm going to put 1,200 parentheses 1 plus parentheses 0.0138 divided by 365 to the power of 365. Enter, and I got 1,216.67. Okay, so right now we already know that this bank isn't as good as the one she already has. Okay, the $1,200 compounded at 1.7% monthly is better than a 1.38% compounded daily. Okay, and now when we go to do this one, it is going to be 1,200 parentheses 1 plus another parentheses 0.019 divided by 4. Close the parentheses up, put a 4 and hit enter. Okay, and now that came out to be 4,000. That's definitely not going to be correct. So what we need to do is adjust this rule. Okay, I think I put just times 4 there. I did at the end instead of to the 4th power. I re-entered this and it's 1,222.96. Okay, so I apologize for that. 1,222.96. I just entered it incorrectly in the calculator. Once I got that 4,000, I'm like, whoa, timeout. It can't be that much more. So anyway, 1,222.96 is the better deal. So she should choose the 1.9% compounded quarterly. All righty. Okay, so now we're on to a different type of problem. We're adding to this, and it says Marie deposits $1,650. And the key here is the difference is for 3 years. The last examples were just how much interest compounded daily for a year, how much interest compounded quarterly for a year, how much interest compounded monthly over 1 year. Now we're talking about more than a year. And then here's our interest rate, and here's our compound daily. All right, so we need to add one more component to our formula. So we were working with, and we derived B equals P times 1 plus R over N to the power of N. But now that's only when we're dealing with 1 year at a time. Now we're talking about 3 years. So now B is our ending balance, P is principal, which it's always been, R is our interest rate, N is the number of times interest is compounded annually. And now we add this T for number of years, okay? But it's really not that much more. So all we're going to do now is write B equals, and we should write the formula just so we memorize it, P times 1 plus R over N to the power of N times T. So then we substitute in our givens, B equals, and I suppose I should do that off to the side, P equals, and it's $1,650. R equals 0.01, 1%, 0.01. T equals, and time is compounding. Actually, now it's going to be N. We're going to call N our time. So that's the difference here. So we're going to change that T to an N, and that's our daily. So that's number of times it's getting compounded. A year is 365, or you could say 1 over 365. And our time is number of years, 3. Okay. So now when we substitute that in, we're going to get $1,650 times 1 plus our rate as a decimal, which is 0.01, over our N. So really, I shouldn't have that 1 here because it's going to just be the denominator every time. It's going to be 365. And then to the power of 365 times 3 and times T. Okay, so when I get my calculator out, it's going to be, let me turn it on. Hello, on, 3 times a charm. 1650 parentheses 1 plus another parentheses for your fraction, and it's 0.01 divided by 365. Close the parentheses for the fraction, close the parentheses for the 1 plus the fraction, go to your exponent, which is where I made the mistake on the last extra understanding problem. And now it's going to be 365 times 3. And I hit enter, and I get $1,700.25. So that is going to equal $1,700.25. So if you ever want to know how much interest you earned, you just take your new balance and subtract the principal, and you'll see that you made $50.25 in 3 years at 1%. Okay, 1% is not very much. Okay, now there's a quick check your understanding. Pause the video, see if you can do this, and come back. So it says Kate deposited $2,350. So that's my principal, $2,350 into an account that earns interest at a rate of 1.1%. So R, that's our R, 0.011, compounded monthly. So that's our N, and that's 12 times a year, and our time is 5 years. Okay, so there's all our values. So you write the balance equals principal parentheses 1 plus R over N to the power of NT. Substitute in the givens, $2,350 parentheses 1 plus 0.011 over 12 to the power of 12 times 5. So B is going to equal, get my calculator, clear it, 2350 parentheses 1 plus another parentheses 0.011 divide 12, close parentheses, twice to the power of 60, 12 times 5, and hit enter, and I get 2482.81, 2482.81. $2,481, rounding to the nearest penny. Okay, so it's $2,482.81. What is her ending balance? So it's B. It didn't say how much interest did she earn, but if you wanted to find that, you take your ending balance, subtract your principal, and the interest is the difference. All right, so pause the video, see if you can do the next extended understanding. It says, write an algebraic expression for the ending balance after K years of an account that starts with a balance of 2,000, interest rate of 1.5% compounded daily. So our principal equals K. Our rate is 0.015. Our N is daily, 365. And our time is, oh, it's K years, I'm sorry. Time is K. And our principal is $2,000. All righty, so now that we've got that, B equals P power parentheses 1 plus 0.0, whoops, we're on write the formula first. Our rate divided by our N to the power of NT. So our balance is going to be the principal, 2,000, times 1 plus 0.015 over 365. Close the parentheses to the power of 365 K. All right. Okay, so I could simplify that a little, but not really. All I could do is make this a different number and take the 1 plus it and find a value. But if we just leave it like this, this answers the question, because that K we cannot actually calculate the actual balance unless we know what K is. Could be 1, 2, 3, 100, who knows? All right, so that's it. Okay, example 4. Sharon deposits $800. There's our P. In a 1-year CD, there's our time. At 2%, there's our rate. Compounded daily, there's our N. Okay, what is Sharon's annual percentage yield to the nearest 100th of a percent? So P equals 8,000. R equals 0.02. N equals 365. T equals 1. Okay, so an annual percentage yield means what percent did this, what was our yield? In other words, 2% is the interest you're earning, but what did it turn out to be? So the annual percentage yield gives a simple interest rate that would be earned in this, the same dollar amount of interest if she began with the same 8,000. It says the APY is more than the APR, annual percentage rate. Annual percentage yield is greater because the APY doesn't give interest on the interest like compounding. Okay, the interest is like compounding, I mean. So since the principles used to compute interest when compounding are not used in simple interest, the annual percentage yield must be higher to compensate for the lower principal used throughout this process. So what we're going to do is use our formula B equals principal times 1 plus R over N to the power of NT. Substitute in everything, and we have 8,000 as our principal. 1 plus our rate, which is 0.02, over compounded daily 365 to the power of 365 times 1 RT. Okay, so look kind of familiar here. Without that T there, we're back to a simple interest. So B equals, and when I go to my calculator, 8,000 parentheses 1 plus parentheses 0.02 divided by 365, close the parentheses twice, to the power of 365 times 1, which is just 365. And I get 8,161.61. $8,161.61. So then if I want to know what the interest is, interest equals your balance at the end minus your principal. So that is going to equal $8,161.61 minus 8,000. So my interest is going to be $161.61. Okay, so now we're going to use the simple interest formula. I equals PRT. All right, so now we know what I is, which is $161.61. Our principal was $8,000. Our rate is what we're trying to find. And our time is 1. So we're trying to find rates. We're going to divide by PT on both sides. Okay, so what does that do? The P's cancel, the T's cancel, and we're left with R equals I divided by PT. So the rate is going to be the interest, 161.61 divided by 8,000 times 1. Okay, so my rate is going to be, so we take 161.61 divided by 8,000 times 1 is still 8,000, so that's all we need to do. And we got 0.0202, 0.0202. So that as a percent is 2.02%. Okay, so that is the annual percentage yield that they need to give in order to get that amount after 1 year of interest. Okay, so there is a shortcut for the annual percentage yield, and let me just bring that in. I'm not going to go over that one, but I will just bring it in. Okay, so here's the annual percentage yield. Rather than doing the compound interest formula and then subtracting and then doing the simple interest formula, annual percentage yield is just simply the 1 plus R over N to the N minus 1. So if I did that, it would be 1 plus our rate, which was 0.02 over, am I doing this right? 365. And then once I calculate that, I subtract 1. So let's just check that. So it's going to be parentheses 1 plus another parentheses 0.02 divided by 365, close the parentheses, twice minus 1. Okay, that did not come out right. 1 moment. Okay, I forgot my power. That would help. This is supposed to be 365. Alrighty then, let's try that again. Parentheses 1 plus another parentheses 0.02 divide 365 parentheses to the power of 365 minus 1. That's better. 0.0202, just what we got here. So what would you rather do? All that compound interest formula and then find the interest and then substitute that into the simple interest formula to find it. So it's a whole bunch of calculations, or just do the simple annual percentage yield formula. 1 plus R over N to the power of N minus 1. Just don't forget your power like I did. All right, so continuing on. Barbara deposits $3,000 in a 1-year CD at 1.1% interest compounded daily. What is the APY to the nearest hundredth of a percent? Check your understanding, pause the video, see if you can do this, and we'll check it. So here we go. APY equals 1 plus R over N to the power of N minus 1. So what do we need to know? We need to know R. We need to know N. So she deposits 3,000 into a 1-year CD at 1.1% interest. So that's my rate, 0.011. Okay, so here, compounded daily, N is 365. So what is her APY? So APY equals 1 plus 0.011 over 365 to the power of 365 minus 1. And when I plug that in my calculator, I get 1 plus 0.011 divided by 365, close the parentheses twice, to the power of 365, get out of the power, minus 1, enter, and it's 0.0111. Or 1.11%. Okay, so what I want to point out there is her principal doesn't matter. You do not need to know the principal to do the annual percentage yield using the APY formula. Otherwise, we would have had to have done the compound interest formula to find how much interest she earned, plugged all that in to the simple interest formula to find it. But I would much rather just plug in R and N and be done with it, wouldn't you? Okay, so extend your understanding. Consider an amount X deposited. Okay, consider an amount X deposited into a CD at 2.04% interest compounded daily, and the same amount deposited into a CD at the same rate, 0.2 or 2.04%, that compounds monthly. Explain why after 1 year, the balance on the CD that compounds daily is greater than the CD that compounds monthly. Okay, so it says, because there are more compounding periods for the interest to be earned on already accumulated interest, the balance grows more quickly on the daily compound than it would at the monthly rate. Okay. And that's the end of lesson 2.2.